In Shanxi province, a waste incineration power plant has been forced to operate on a schedule of 3 months of operation, followed by 1 month of shutdown, all due to a shortage of waste. This is not an isolated case. China's total waste incineration capacity of 135,000 tons per day is facing an annual shortfall of over 60 million tons. This paradox reflects a dramatic shift in China's environmental policies. Not long ago, garbage piles around Beijing reached 80 meters in height. In Shanghai, 26,000 tons of waste were produced daily, requiring 2,000 trucks for transportation. Today, with 43% of the world's waste incineration capacity concentrated in China, incinerator operators are now fighting for waste, like in a Hunger Game. The seeds of this crisis were sown as early as 2000. When German waste incineration technology was first introduced in Shenzhen, no one anticipated it would grow into a nationwide infrastructure movement. In 2017, 5 major Chinese government departments issued a joint document encouraging local governments to plan ahead for incineration facilities. That ignited the competitive race. Data shows that China's waste incineration capacity skyrocketed from 10,000 tons per day in 2002 to 1,035,000 tons per day in 2024, an increase of nearly 100 times. In Hebei province, the planned capacity for 2025 is 70,000 tons per day, which far exceeds the actual demand. In Jiaxiang County, Shandong province, the incinerator's actual processing volume is less than 50% of its design capacity. Behind this rapid development is the local government's competition for franchise rights. Every incineration project means a 20-30-year fiscal subsidy commitment and GDP growth from land development. Since 2019, China has enforced mandatory waste sorting, but this policy has inadvertently become a catalyst for the country's waste shortage crisis. Official data shows that while Shanghai's wet waste diversion increased by 88.8%, the amount of incinerable dry waste dropped by 17.5%. In Beijing, waste sorting led to the cancellation of 2 large incineration plants that were originally planned. This success is now transforming into industrial growing pains. Incinerators are designed to process waste with a calorific value of 1,200 kcal, but sorted dry waste has a calorific value exceeding 1,800 kcal. Theoretically, this could improve power generation efficiency. However, fluctuations in calorific value make furnace temperature control difficult. Frequent starts and stops increase the risk of pollutant emissions. To meet the waste needs of incineration power plants, many Chinese cities have begun to excavate waste buried underground over a decade ago. This waste archaeology has become a helpless choice for many incinerators. But untreated aged waste carries heavy metals and dioxins, which makes emission control more challenging. In Changzhou, Jiangsu province, incinerators have tried to expand their processing to include clothing scraps and furniture waste. In Dongguan, Guangdong province, incinerators sell surplus heat to nearby printing and dyeing businesses. These innovations are a response to the industry's survival crisis. Policy changes are also on the horizon. The revised Standards for Pollution Control of Domestic Waste Incineration propose expanding the protective distance from 300 meters to 1,500 meters. This would directly eliminate 30% of existing facilities. More radical suggestions come from the Development Research Center of the State Council. They recommend establishing a cross-provincial waste allocation mechanism. This would allow regions with surplus capacity to bid for processing waste from neighboring provinces. But all these solutions face a fundamental question. As waste sorting continues and waste reduction becomes inevitable, should the logic of waste as a resource be redefined?